Hey, Miss Marion here. So we have a quiz tomorrow. So let's go ahead and go through some of these things. You should have a packet that goes along with these questions. Make sure you take some notes so you make sure you understand tomorrow's quiz. All right, so here's number one. It says, one gathered data at a school among 5th and 6th graders to see if there was an association between grade levels and those who take drama. The table shows his data, but the number of fifth graders who prefer cold lunch is missing. So notice how we have this missing right here. Consider the relative frequency table to help in determining your answer. So notice how we have 38%, 38%, 63%, 63%. Okay. Juan found that there is no evidence, so no evidence of an association between the grade levels, so between grade levels, and those who prefer cold lunch. Which of these could be the number of 5th graders who prefer the cold lunch? Okay, so this is kind of weird. And so we have to look into being able to go ahead and fill in this one here, right? And the way that we do that is we're looking at per grade. So let's find the totals per grade. So we're going to go ahead, and we only have the 6th graders, so we're going to go 18 plus 30, and that is 48. Okay, and then eventually we want to find the other totals that kind of go along with it, and eventually we want to fill in this part here. So notice if we do 18 divided by 48, we get 0.375, which is the 38% that you see here. Okay, and then notice how if we do 30 divided by 48, let's put that in a different color. So we have 30 divided by 48. Grab your calculator. That is 0.625, which is the 63% that goes here. So notice how we have all these different numbers down here. Okay, so we have 18, 28, 42, 28. And one of these numbers needs to come into here. We add the two numbers together, and eventually it's going to make 63%. Okay, so that's kind of what we're looking at as far as what number is going to go ahead and be in there. So let's try 18. So if I put 18 in here, right, I would do 12 plus 18. 12 plus 18 is 30. And if I do 18 divided by 30, is that going to give me my 63%? 18 divided by 30. No, they gave me 60%. All right, so that doesn't work. Let's try a different one. So let's see if I put 20 in here. So I say 20. Let's do it the same format. So let's do 12 plus 20 equals 32. And we're going to do 20 divided by 32. So 20 divided by 32. That, if we round it, is 63%. Okay, so that's kind of what we're looking for. Let's try the other two just to make sure. So we're going to say 12 plus 42. 12 plus 42, that's 54. And then 42 divided by 54. That's 78%. And then last one, we're going to do 12 plus 28. 12 plus 28. Okay, that's 40. 28 divided by 40. That's 70%. Okay, so notice how we want to make it so there's no correlation, meaning that we need to have 63% here. So what number works for 63%? That's the 20. So our answer is going to be 20. All right, so here's example number 2. Sage and Oscar gather information among 7th and 8th graders to see if there was an association between the grade levels and those who prefer math. The table shows their data, but the number of 8th graders who prefer math is missing. Considering the relative frequency table to help in determining your answer. So notice how we have 64%, 64%, there's no difference. And then 38, 36, and 36. So eventually we want to make 64% here. So go ahead and pause. You guys try it this time. Go ahead and pause, try it, and then come back to me to see if you got the right answer. All right, so we're going to go ahead and try these. So I'm going to say 20. Well, let's do the same order. Okay. Let's do 22 plus 20. That's 42. And then I'm going to say 22 divided by 42. 22 divided by 42. That's 52%. Nope, looking for 64. All right, so now I'm going to say 20 plus 20. 42. Or not 42, that's 40. And then I would say 20 divided by 40. That's 50%. Nope, I need 64%. Let's do 55 plus 20. That's 75. And then we're going to say 55 divided by 75. Ooh, that's 73%. Not yet. And then let's do 36 plus 20. 36 plus 20 is 56. And then we're going to say 36 divided by 56. That is 64%. So which one made the 64% that we want? That is 36. All right, so let's look at example number 3. So example number 3 says, a principal of a school with 484 students collected information about how many students wear glasses. So first of all, we need to complete the table. How many boys sometimes wear glasses? We're going to answer the questions. How many students wear glasses some of the time? How many students never wear glasses? And then we're going to do a two-way table, relative frequency two-way table by row. Awesome. All right. So we have 484 students total. So that goes way down here. And so notice, remember that we can add crossways. So let's do 36 plus 55 plus 144. That's 235. And then remember that if we add these two together, it's going to make the 484. So if I do 484 minus 235, that's 249. All right, and then remember that if we add these together, we get the last one. So we're going to say 249 minus 161 minus 40. We're going to get 48. All right, so remember, we're just kind of filling in this table as far as what it's given to us. Let's add downward. So we have 40, 36. That is 76. Let's add 48 and 55. That's 103. And then 161 and 144. That's 305. And then let's check and make sure these totals all add together. So we're going to say 76 plus 103 plus 305, 484. All right. So notice how we just kind of worked with the pieces of information that was given to us to go ahead and answer these questions. So now we're going to do a relative frequency by row. All right. So we're going to make it a two-way table. So we have it as always wear glasses. This is sometimes wear glasses. This is never wears glasses, right? Then we have boys. Remember, this one up here never is filled in, okay? Then we have girls. And we're doing it by row. So row is going across like this. So we're going to use this total, and we're going to use these ones in the middle, okay? So we're going to say 40 divided by 49. So I have 249. Sorry, my pen's kind of loud. And if we go ahead and we're going to divide that out, do 40 divided by 249, we get 16.06, right? We want to round it to 2 decimal places, so this is going to be 16%. So that was 40, right? Let's keep on going. Now we're going to do 48 divided by 249 for the sometimes. So 48, 249, and that's going to be, if we look at it, we have it as 19.27, right? So that's going to be 19%, okay? And then never is 161 divided by 249. And that's going to be 65%. All right, because we have 0.646. We want this one. We look at the next guy next to him. Is it 5 or above? Give the original a shove. Okay. Now we're going to do the other row. So we're going to do 36 and 235. So we're going to say 36 divided by 235. Oh, we never answered all the other questions, but that's okay. So we're going to say 36 divided by 235. We have 15%. We have 55 divided by 235. 55, 235. That's 23%. And then we're going to say 144 divided by 235, because this is row. Row goes side to side. 144, 235. And it's 61%. Okay, so this is our relative frequency by row. Let's go ahead and, we forgot to answer all the other questions. It says complete the table. Yep. All right, how many boys sometimes wear glasses? So boys, and then sometimes that would be 48. How many students wear glasses? So overall of all the students, how many all of them wear glasses? So we're going to look at it. Oh, sometimes wear glasses. So that's 103. So sometimes. And then how many students never wear glasses? That's all the students together who never wear glasses. That would be 305. Okay, so make sure you understand how to do this type of question. Again, we'll be on your quiz tomorrow. If you don't understand it, pause it and then go back and then come back. All right, so moving on to example number 4, we have this graph here, and we want to find which of these equations is going to be a good line of best fit. So noticing here, this is a positive association, right? That means we're supposed to have a positive slope. So I'm going to look at these. Does this one have a positive slope? No, it doesn't. So I'm just going to mark it out just right now. Does this one have a positive slope? Nope. Let's cross it out. All right, and then now we're down to just these two, okay? So I'm going to look at it and go, okay, notice how on this one here, my slope is 2, my y-intercept is 5. So that means my y-intercept needs to start here and then go up. Does that work? Not very much. Let's try the other one. Bottom one, my slope is 3. My y-intercept is -1. So -1 would be down here and then go up. Does the blue one work? That one works better. So which one would be the better as far as a good line of best fit? Well, that would be this last one here. All right, here is example 5 and example 6 together. And it says select all that are true for example number 5. So we're looking at this. So is this a positive association, reading it from left to right? Does it go up the hill? Nope. Okay, so not positive. Is it a negative association? Yes. Okay. Is this linear, non-linear? So if we put a line in between the information, oh yeah, it is. Notice how that does curvy, so it's non-linear. Are there any clusterings? Not really. I mean, and so we could say in a way, but the best two answers would be negative association and nonlinear association for example number 5. All right, example number 6. Let's go ahead and make a scatter plot that is a positive nonlinear association. So positive needs to go up the hill. Nonlinear needs to be curvy. So here is my scatter plot that is a positive nonlinear association. All right, let's look at example number 7. The graph shows the line of best fit for the data collected and amount earned by waiters and waitresses last week in relation to the number of tables they served. What is the equation that is for the line of best fit? So we have this line, and we want to find out which one of these equations would be better here. So first of all, I'm going to notice the y-intercept. So if I look at it, my y-intercept is this person, this guy right here, right? And so notice how that is around 300. And so, well, like 350, I guess, because it's in between 250 and 500, right? So would this one be a good, so notice how this is 3 as the y-intercept. Does that work? No. Okay. Does 375, 475, and 375. So we have kind of these ones that go along with it. So now we need to figure out our slope. So I'm going to pick 2 points off this line. And I'm going to pick this one because it's really nice. I know what that one is. So that point is 75, comma, because notice how it goes blank 50, blank 100, right? So 75, comma, 500. And I am also going to pick this point here. And then what's that point? That point is 225, comma, 750. All right, and then let's go ahead and find our slope. Remember, it's y2 minus y1, x2 minus x1. So we're going to say y2, 750, minus y1, 500, 225, minus 75. Let's grab our calculator. Let's do 750 minus 500. We get 250. I'm going to say 225 minus 75 over 150. And then I'm going to put that in my calculator. And I'm going to get 1 2/3. Okay, so remember, all right, so that's a mixed fraction, but I want improper. So we can take it and we can change it into an improper fraction. So let's do 3 times 2, which is 3, add the 2, which is 5, so that's 5 over 3. So this is my slope. So I have a y-intercept around between 250 and 500. I have a slope of 5 over 3. So notice how this one is not a slope of 5 over 3, and either is this one. But notice how this one is. So is this a good line of best fit? Yes, it is. All right, example number 8. It says the scatter plot shows the price used car and the time since purchased the car. A computer program found that the line of y equals negative 750x plus 11,000 is a good line best fit. Use the equation. Okay, so remember, use the equation. Project the amount, the price of the used car that would purchase after 7 years ago. So 7 years ago. So we have our equation. So minus 750 x 11,000. And notice how time since purchased in years. And then we're given the years. So that's our x. So we're going to take that 7 and we're going to put it in. So we're going to say negative 750. Remember, this is times. And then our years is 7. And then we're going to add 1100 onto it. Grab your calculator, put that in. And we're going to get 5,700. And we're going to put money with it. Would be the answer. So 5,750 would be our answer for this. All right, so this is our quiz review. So make sure you go ahead and go through this and make sure you do it correctly. And make sure you understand it because, yeah, this is going to be our quiz for tomorrow. All right, have a good day. Thanks. Bye.